Hello everyone, my name is Glen Owen and today I'm gonna present you about my lecture and it's about thermal physics. So let me share my screen to the PowerPoint for a while and let's see. Right. Alright. In here we already have my first PowerPoint slide, which is thermal physics basics by created by myself. And here, before I started, what I'm gonna teach you guys today is about just general information about thermophysics basics. So what I included in this PowerPoint, there will be some general information and then about some measuring tool that we used for thermophysics and their units and also some example questions. So yeah, let's get into it. Alright, here are the general information. So first of all, we have heat. Now, heat is the transfer of energy from one particle to another particle. So you can say that heat is the process of transferring from transferring energy from one particle that it has some heat to another particle that maybe has no heat or maybe have heat but a little amount of it. And yes, that's the first general information. And the second one, we have thermal energy. So thermal energy is the energy that's generated and transferred by heat, which refers to an internal energy in the form of an average kinetic energy caused by the movement and collision of particles or molecules. In here, you can say that. And yes, a thermal energy is one of the type of kinetic energy since it's caused by some movement and collision from the particle itself. And this energy is these energies generated and transferred by heat. And so yeah, when heat is transferring, they use thermal energy. Okay. And now for the last general information that I will give is that temperature. Now, temperature refers to the measure of thermal energy, which is the degree of hotness and coolness of a body. So, well, that to be well, according to myself, that for me to say, uh, for to say it easy, that is that temperature is the one that you guys always see whenever you guys want to check your body temperature. There will be some number that will generate it in a something that is called thermometer. Then they will generate some number. That number will have some degrees and other units, right? Like, well, for general, they will use Celsius or maybe Kelvin. And yeah, the number that is generated is the temperature that your body or other substance that has. And yeah, and there's all for the general information that according to myself. And now we're going to discuss about um, the measurement, the measuring tool of thermophysics. So we all know that's the measuring tool for thermophysics, of course. And yes, the name is thermometer. Thermometer is a measuring tool to measure temperature, of course. Now, thermometer classifies become two types. There's classification of thermometer, which classify it to two types. So the first one is according to the uses, and the second one is according to the liquid use. Now, let's say here, there's three thermometer in according to the user's one. So what do you think? What do you think this thermometer is? Like, do you know what's one of them at least? Right. So the first one in here, the blue and white one, is the clinical thermometer. It's basically used in a clinic, of course. And yeah, it's because the name itself, it's obviously used in clinic or maybe in uh, hospital. Sometimes used in the hospital. And the second one in here, in the middle one, is the laboratory thermometer, which is used in laboratory. And the last one you see here, the one that there have Celsius degrees and the Fahrenheit degree. Well, maybe some of you know and some of you didn't. So yeah, this thermometer is called atmospheric thermometer. This thermometer measures the atmosphere temperature. Now, according to the liquid used, here are some examples that I'll show you now. Now, this thermometer and this thermometer is of course different. As you can see, the liquid using is this one has a black liquid and this one has a red liquid. But don't get me wrong, they're not using black ink and red ink. These are special liquid they're using. So the black liquid thermometer, it's called the mercury thermometer, and the red one, it's called the alcohol thermometer. And yes, these are the classification of thermometer. Well, I can only give you 5 thermometers there, since that's only what I know. And now we're going to the units of the temperature itself. And yeah, let's get into it. So first, units of temperature. Well, of course, some of you guys know about the unit itself. Some already know and some maybe didn't, or maybe they forgot about it. I'm just gonna recall it, and here it is. There's for general there's 3 types, but in here I'm just going to give at least 5 types of units of temperature, of course. So the first one is Celsius scale, or sometimes people call it degrees Celsius. This scale was invented by Anders Celsius. And the second unit, it's called the Fahrenheit scale, or Fahrenheit degree. This scale invented by Gabriel Daniel Fahrenheit. And third one is Kelvin scale, or maybe simply people write it in K. It's invented by William Thomson, aka Lord Kelvin. And fourth one, there's Reaumur scale, or simply write it as degree R. This scale was invented by Reine-Antoine Verschool de Reaumur. And the last scale, which is very rarely used according to myself, which is called the Rankine scale, or simply write R with no degrees. This scale was invented by William John McCorn Rankine. So each scale of this temperature has their own freezing point, boiling points, and also their own range. Well, some of their range will be the same, of course. Now the first one, I'll be showing the Celsius scale. In here, you know that the Celsius scale freezing point is 0, and the boiling point is 100 Celsius. And the range between the freezing point and the boiling point is 100. So maybe some of you don't know what's freezing point and boiling point. Well, I'm just gonna explain it simply. Well, just imagine you are boiling a water. When you want to boil a water, you need to, of course, um, you need to heat up the fire or maybe stove. I don't know, but yeah, if you want to boil it, you of course need the heat source go to a certain degrees so that the water will boil. And here it comes. The water will boil in 100 Celsius. But if you want to freeze the water instead, you need to lower the temperatures from the water into zero or maybe below zero until it freezes into an ice cube. And this range is just the range between the freezing point and the boiling point. And now, after I explained already, now let's get it. Let's continue to the Fahrenheit scale.
So in here, the Fahrenheit scale, the freezing point is 32 degrees Fahrenheit and the boiling point is 212 degrees Fahrenheit, which means the range will be 180 between 32 and 212. The range between these numbers will be 180. Next, for the Kelvin scale, the freezing point will be 273 Kelvin, and the boiling point will be 373 Kelvin, and the range between this point are 100, same like Celsius scale. And the fourth one, the Reaumur scale, the freezing point, same like Celsius, is 0, but the boiling point is different because Reaumur is 80 degrees Reaumur, and the range between this point are 80. Now for the last scale, which is the Rankine scale, is a little higher than the others, since I also don't know why it's high, but it's stated already by William John Rankine, which is the freezing point will be 492 R and the boiling point will be 672 R. The range between these points are 180, which is the same just like Fahrenheit.
Alright, since all of these points are given, now maybe some of you will ask me, what will this point do? What will we do with this such numbers, random number like this? Well, we use these numbers to, of course, to convert, for example, this scale, Celsius scale, to another scale. But and then some of you may think like, how do we do that? Well, simply we have their formula, which is, yes, the formula will be the given temperature minus the freezing point of each scale. For example, if the given temperature is Celsius, then you use the Celsius freezing point. If the given temperature is Kelvin, then you'll use the Kelvin freezing point, and so on. And for the range, it's also for each scale, just like before, if you use Celsius scale, then you'll use the range of Celsius. If you use Kelvin scale, then you'll use the Kelvin range. Alright, since I'm done explaining the units of temperature, now for some example questions. Let's get into it. Alright, in here I have 3 questions. Some of you may answer it, but here I'm just gonna explain it. How will we answer it? So if you may, you can get your notebook or maybe some paper and write just like what I will say now. Now, to convert 69 degrees Celsius to Kelvin scale, you need to write the formula first, given that you write, you know what, let me just show the answer so it's simpler, then I'll explain it to you guys. Right, in here, as you can see, sometimes people will see it is like complicated since there's so many numbers, but no, it's It's simple. It's as easy as peanut. So in here, there's 69 minus 0 divided by 100, which means this 69 is the given temperature from Celsius. This one is Celsius and this one is the Kelvin, since we want to convert Celsius to Kelvin. And if we want to convert this to Kelvin, we have to use the equal. Okay, so let me explain a bit. 69 is the given temperature of the Celsius. 0 is the freezing point of Celsius scale, and 100 is the range of Celsius itself. In here, in this one, in the right one, we have T minus 273 divided by 100, which means T is the temperature of Kelvin that we have to find, minus the 273, which means the freezing point of Kelvin scale, and divided by 100, which is the range of Kelvin scale. Now, since we only want to find the T, let's we observe it for a while. Since the below is 100 is already equals to 100, we may ignore that. So we'll just focus on the 69 is equals to T minus Y minus 273, which in here. After that, you'll be transfer this 273 into the left side so that it will become positive 273. Then you'll add 273. You may grab your calculator. 273 plus 69, and your temperature in Kelvin scale will be 342 K. I hope you guys understand that. Now let's continue to the second question.
Here we are given that the Reaumur scale is given 42.0 Reaumur degree. You have to convert this to Fahrenheit scale. And yeah, let me show it to you guys. This is my solution. And yeah, since we have this 42.0, it's mean that we have to use the significant figure rules. And yeah, I hope you guys know how the significant rules work, because I'll not explain to you guys, since I'm in here to explain the thermophysics. Now, given that, so we just insert this into the formula, just like before. 42.0 minus the freezing point of Reaumur divided by range of Reaumur, which is 80, is equals to the temperature of the Fahrenheit minus the freezing point of Fahrenheit, which is 32, divided by the range of Fahrenheit scale, which is 180. Now, since we have different numbers in below of this fraction, all you have to do is to cross multiply this, like 42.0 multiplies by 180, and 80 times T minus 32. After you cross multiply it, you have 42.0 multiplied by 180 equals to 80 T minus 2560. Now, let's calculate first the multipliers in the left side. So grab the calculators. 42.0 times 180, it will become 7,560. But why in here I use 7.56 times 10 raised to 3? It's because I follow the significant rules, which is in multiplier, we'll follow the number of significant rules in the given number, like 42.0, which is at 3 numbers, so I follow it and make it 7.56, which is 3, and this 10 raised to 3 is just ignored already. Okay, we'll just ignore that. After we multiply this, now we have 80t minus 2560. Now this 2560 will move this to the left side, and it will become 7.56 times 10 raised to 3 plus 2560 equals to 80t. Now we add the left side, so 7.56 times 10 raised to 3 plus 2560. Okay, wait for a while, I'm just gonna calculate my calculator. The result in the left side will be 10, it's supposed to be 10,120. Now this 10,120 will be divided by 80 to remove the 80 in the right side so that we can get T itself. And the final answer will be the T in Fahrenheit scale, or temperature in Fahrenheit scale, will be, yes, 1.27 times 10 raised to 2. Now, maybe some of you guys in their calculator, the result will be 126.5. Why I use 1.27 times 10 raised to 2 is because I followed the significant rules, which is when the given significant number is 3, then the final answer will be 3. And yes, in here, I use 1.27 and not 1.26, since 126.5 is, we'll round it off to become 127, then we'll convert it, I'll convert it into this comma sign, since if you use whole number, if you use the full number, it will not count to be a significant figure according to my teacher. So yeah. Next, for the final question, we need to convert 500 Rankine scale into Celsius scale. So yeah, just like I said, I will show it to you guys, the solution, and I'll explain it to you guys. So just as usual, we'll just put the given number. We have 500 Rankine minus the freezing point, which is 492, divided by its range, which is 180, equals to the Celsius temperature minus the Celsius freezing point divided by range of Celsius. Since the number below of us are different, then of course we will cross multiply it again. So before that, we have to make it simpler. So this 500 minus 402 we'll subtract it, and it will become 8. So 8 times 100. Then in here, we have 180 times t minus 0. So 180 times t is 180 t, and that's it. So we'll have 8 times 100 equals to 180 t. Now we'll multiply this, the left side, which will result as 800. 800 equals to 180 t. Then to remove this 180 in the right side, we need to divide all of this to 180. So 800 divided by 1. 800 divided by 180. And the last one, the temperature of Celsius scale will be 4.44 degrees Celsius.
And that's it for my presentation. That's it for my presentation. I hope you guys at least know some of this, at least understand what I'm explaining to you guys. And see you on another lecture, video, or project making. Thank you very much.